In this video, we are going to understand the formation of covalent bond. Now let's begin with hydrogen. What we know that hydrogen atomic number is 1 and it has 1 electrons in the outermost shell. As you can see, it is H2, so another hydrogen with 1 electrons in the outermost shell. I can figure out that hydrogen need 2 electrons in the 2 electrons to attain the stable gas configuration. So you can figure out that hydrogens share this one pair of electrons to form a single covalent bond between hydrogen and hydrogen atom. This is how the hydrogen molecule is formed. Now, next is oxygen. You should remember that oxygen, whose atomic number is 8, configuration is 2, 6. That means this oxygen atom will have 6 electrons in the outermost shell. Now, it has these 6 electrons such that it will share one pair of electrons. So you can see O2 with 2 oxygen atom. These are the dots indicating the electrons. As you can see, the other oxygen, let me use color for you to understand better. So if I take another oxygen atom, the other one, it also has 6 electrons. As you can see that they will share a pair of electrons here, and this oxygen now will have 8 electrons, which is a noble gas configuration, and this oxygen too has 8 electrons. So this way we can say that oxygen has double covalent bond. So you should know that a pair of electrons indicate a single bond. So now oxygen has a double covalent bond. So this is how oxygen molecule is formed. Now coming to the next is nitrogen. Nitrogen, whose electronic configuration, atomic number is what? 7. So configuration is what? 2, 5. So you can figure out from here that nitrogen has 5 electrons. So it needs 3 more electrons. So what it does, it keeps 3 electrons, say here, and the remaining 2 with itself. Now, the other nitrogen atom will also do the same thing. You can see that now they share one pair of 3 pairs of electrons, right? These pair of electrons are being shared. So you can, from here, you can see that now this nitrogen has 8 electrons and this too has 8 electrons. So this way nitrogen forms triple covalent bond. As I said, a pair of electrons indicate a single bond. So they have 3 pair of electrons being shared, so they will form triple covalent bond. This is how nitrogen forms a bond. That's a triple covalent bond. Now coming to the next example, that is chlorine here. Chlorine, you can should know that chlorine, whose atomic number is 17, electronic configuration is 287. So you can see from here that chlorine just need one more electron. So they will share, these chlorine atom will share 1 electron each. So let's say I write this 2 chlorine here. This chlorine has, I'm using dots here to indicate the number of electrons. This is 4, 5, 6, and this 7th electron over here. The other chlorine atom, 1, 2, 3, 4, 5, 6, and the 7th electron over here. Now you can see that this chlorine will now have 8 electrons, so is the other chlorine atom. This way, chlorine forms single covalent bond, and the chlorine molecule is formed like this. Now, once we have done chlorine, next will be H2O. Now, for water, you can see that it has 2 atoms of hydrogen and 1 atom of oxygen. So let's begin with oxygen. Oxygen, whose atomic number is what? 8. So configuration is 2, 6. It has 6 electrons in the outermost shell, needs 2. Hydrogen has 1 electron, needs only 1 electron. So what will happen here is this hydrogen will have 1 electron, this hydrogen will have 1 electron. Oxygen, as you can see that it has 6 electrons, so it will first place, say here 1, 2, 3, 4, 5, and 6. Now from here you can see that this hydrogen needs 2, got 2, needs 2, got 2, and this needs 8 electrons. So this way you can see that oxygen molecule single covalent bond, and this is single covalent bond. Well, these are unshared pair of electrons. So this is how oxygen combines with hydrogen to form H2O as a covalent bond. Next is what? Methane. Methane is CH4. So let's first write carbon. Carbon whose electronic configuration, if you see carbon, is 2,4. Let's say if I write here, carbon atomic number 6, so electronic configuration is 2,4. It has 4 electrons in the outermost shell. So it will keep all 4 electrons, say, on 4 side, so as hydrogen with atomic number 1 and 1 electrons only in the outermost shell. So this hydrogen will have 1 electron, this hydrogen will have 1 electron, this hydrogen with 1 electron, and this hydrogen with 1 electron. Now, hydrogen, as we know, needs 2 electrons to get satisfied by taking these 2 electrons. Now, carbon in turn needs 8, and it will get 8 electrons. As you can see that this way it can get 8 electrons. So now carbon forms single covalent bond with 4 atoms of hydrogen to form the molecule methane. This way it will form molecule methane. So now we have done methane. We'll do the next one. Next is carbon dioxide, carbon with oxygen. Carbon whose atomic number is 6, so configuration 2,4, and oxygen with atomic number as 8, configuration 2,6. You can see that oxygen needs 2 and carbon needs 4. So what carbon can do, it will keep these 4 electrons, and the oxygen atom, say this is an oxygen atom, will share 2 electrons, will keep the remaining 4 with itself. This oxygen will do in the same manner. Now check here. This oxygen has 2 plus 2 plus 4, that is 8 electrons. 4 plus 2 plus 2, 8 electrons. And the carbon here is 4 plus 4, 8 electrons. So carbon now forms double covalent bond with oxygen to form the molecule here, and the molecule is what? This is carbon dioxide. Now, once we have done this, next is what? This is ammonia. That is NH3. So nitrogen, you should know nitrogen atomic number is what? 7. So electronic configuration is 2,5, having 5 electrons in the outermost shell. Now nitrogen knows that if, for example, if it forms bonds with hydrogen, hydrogen takes only 1 electrons. So this way, you can see that this nitrogen will keep 1, say it is 1, 2, 3, 4, and 5th electron like this. Well, hydrogen with 1 electrons forms a bond, with 1 electrons forms a bond, and another hydrogen like this. So from here you can see that this hydrogen got 2 electrons, 2 electrons, 2 electrons, and the nitrogen with 2 plus 2 plus 2 plus 2, that is 8 electrons. So you can see from here that this nitrogen single covalent bond with hydrogen, single covalent bond with hydrogen, single covalent bond with hydrogen. And it should also indicate these are the 2 unshared pair of electrons. So we have done ammonia. The next is what? Next is sulfur molecule. Okay. The next I'm going to do is the sulfur molecule. Yes, S8 with a sulfur whose electronic configuration is what? 286, 6 electrons in the outermost shell. So this sulfur forms a ring-shaped chain. So what you can do here is to write, say, 1 sulfur over here, another here, the 3rd, 4th, 5th, 6th, 7th, and 8th. Now figure out that this sulfur molecule have 8 electrons. So 1 above, 1 below, 3, 4, 5, 6. Same way, from here you can count. This is 1, 2, 3, 4, 5, 6. So now you can keep on doing 1, 2, 3, 4, 5, 6, 1, 2, and then 3, 4, 5, 6, 4, 5, 6. This sulfur molecule will keep one electron here, 2, 3, 4, 5, 6. This sulfur molecule has 1 here, 2 here, 3 here, 4 here, 5 here, 6 here, 1, 2, 3, 4, 5, 6. Now, when it comes to forming a molecule, what you have to remember, use same color. Well, you can either put cross or dot. Now, this sulfur molecule will share one pair of electrons, and with the first and with another. Like this sulfur molecule will share one pair of electrons with this and one paired with this. So same, you can see now it has 8 electrons. This to have 8 electrons. This will have 8, 2 plus 2 plus 2, 8, 2 plus 4 plus, wait, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. So this is how sulfur molecule is formed. This is the electron dot structure of sulfur. Now, if I have to make its bond structure, well, this sulfur molecules make a bond structure that is similar to a crown. So what you have to do is to write W. You write W here and write another W starting from here. And merge with this. All you have to do is to place a dot, cross, or even sulfur molecules at each vertex. 1, 2, 3, 4, 5, 6, 7, 8. So this dot here is what's S here, that is sulfur. This is how sulfur molecule is formed. Now, after that, we will do the formation of other saturated and unsaturated compound in the next video.